Hi everyone, so welcome to this video solution. I'm Dheeraj and I'm recording this video at 2 a.m. in the morning. What I'm going to do here is I'm going to show you the application of linear algebra in control system, right? So you know the topic in control system, that is state space analysis, okay? And in GATE 2024, there was one question, right? That can be done with the help of linear algebra concept. In fact, with the help of eigenvalue approach, in very less time, okay, where you're going to invest around more than 3 to 4 minutes if you refer any other solutions, right? So many coaching in India, they have given their solution, but they have solved that question using some shortcuts, or you can say using but those shortcuts are applicable only after finding some, after investing some minute, okay, over that. But now the technique that I'm going to tell you, right, will be based totally on the mathematics. And if you know linear algebra, if you have watched my linear algebra session, right, certainly you're going to solve this question within very less time. Let's move to that question. So this was a question for 2 mark. Okay, let me go through the question here. So this question was for 2 mark. Okay, from control system. Okay, from control system, and I'm just going to solve this question using mathematics. Okay, in fact, the linear algebra, right? So consider a system as, so they have given one system that is nothing but a state space representation only. So which of the state space representation given below has or have? So it is a MSQ question, right? So certainly if it is MSQ question, you're going to invest more time, right? Okay. So you can match my solution with any other solution in India existing, okay? You will find, you can say, I'm going to optimize, I'm going to save a lot of time for you, right? So I believe you will appreciate it. So which of the state space representation given below has have the same transfer function as that of S? Okay, as that of S, right? So whatever is given, you have to find that which state space representation given in the options have got the same transfer function. Now how you're going to solve this question? See, one approach is, I think many of you might have the solution given by various institute in India. So first of all, you will find the transfer function, okay, from for given system. Then you're going to use some shortcuts if you know the shortcuts, okay. But you have to first, find out the transfer function from that. Then you have to match which transfer function, is same, okay, corresponding to each options, right? So, but I'm just going to use linear algebra approach. That is why I always emphasize people go through mathematics before you begin your actual subject, okay, before you begin your core subject, because mathematics is going to play an important role, right? Let's move to this question, okay. So what you can do here is, I'm just going to tell you one very important concept, right, to solve this kind of a question, okay. So to find which state space representation have the same transfer function, okay, as given in this given system, okay, we can use the fact that the transfer function of state space system representation, or represented by what? The transfer function formula, I think everybody knows. What is that transfer function formula? That is nothing but C times Si minus A inverse B plus D. I think everybody knows this formula. So there are some matrices, you see, there is a C matrix, there is a B matrix, there is a D matrix, and there is a matrix, okay. So we must use this fact that the transfer function of state space system will be represented by what? The matrices A, B, C, D, right? But transfer function depends upon the matrices A, B, C, okay. Transfer function depends upon the matrices A, B, C, okay. We must know that. So we don't need to calculate entire transfer function now, okay. So you don't have to calculate. Don't calculate. Calculate, okay. Transfer function. You don't have to calculate in this question the transfer function, okay, because your transfer function depends upon these A, B, C. If you know this formula, transfer function is equal to C times Si minus A inverse B plus D. Otherwise, if you're going to compute the transfer function for given system as well, it will take time, because you have to just plug here. First of all, you have to find SI minus A inverse, then plug C, plug B, multiply and evaluate it. Okay. So since the transfer function depends upon A, B, C, D, okay, I mean ABC, we don't need to calculate the entire transfer function. Okay, if we recognize certain property, okay, so you have to identify the important property. So when you can say that two system will be having a same transfer function, when you can say that two system will be having the same transfer function, so remember that two system, okay, have the same transfer function, because they are asking you to find out the system which has same transfer function. Okay, what they're asking the system which has same transfer function. So my what is my statement here is, you don't have to waste time finding the transfer function, because you're going to again, finding Si minus A, then inverse, then put C, B, multiply, get the transfer function, and then match the options. Again, you have to find the transfer function, or you can use some shortcut over there, right? So, but where we are going to consume time, right? So the time is going to get consumed while finding the transfer function of given system first. Then you will go to option, and certainly you're going to leave this question in the gate examination. I'm pretty sure about it. But once you will know this property, if you're able to recognize the property, two system have same transfer function, if they have same characteristic polynomial, if they have same characteristic polynomial, okay, same characteristic polynomial for a very important concept. Okay, so I think I need to yeah, two system will be having a same transfer function if they have same characteristic polynomial for a matrix A. Same characteristic, what is the meaning of that? This, same characteristic polynomial means same eigenvalue of A, right? Same characteristic polynomial means same eigenvalue. Okay, same eigenvalue for A. So either you can say same eigenvalue, okay, two transfer functions, or you can say two system will be having same transfer function if they have same eigenvalue for A matrix only, guys, for A matrix, or you can say that same characteristic polynomial. I believe everybody knows how to find characteristic polynomial, okay, from the matrix. And in this question you will find that all the A matrix is nothing but 2 by 2 matrix. It's very simple to find out characteristic polynomial, right? I have taught also in in linear algebra. So two system have same transfer function if they have same characteristic polynomial for a matrix A. If same characteristic polynomial means what? They will be having same eigenvalue. Okay? And if the product in, you have to add extra, if the product CB remains the same, and if product CB remains same. So if you have attended my sessions, okay, on control system, I will always tell you these techniques. Okay, then you can say, yeah, two system will be having same transfer function. So in this question, you don't have to do anything. What you have to do, you have to just find the characteristic polynomial, okay, for each matrix A, and you have to see all, all characteristic polynomial that you're going to obtain from matrix A must be same. It means that is the indication of what? Same eigenvalue for a matrix A, and CB must be same, right? So let us compute for given system first. Okay, so this is a matrix A, right? So you can find here. So what is the characteristic polynomial? That is going to be lambda square minus trace of A. Trace of A, that is, what is trace of this matrix? That is going to be 3. I mean minus 3, then it will be plus 3 lambda. And what is det? that is going to be, uh, you can say that 0 and this is 2. So this is the characteristic polynomial you have got. And what is CB, sorry. So this is C, this is B, this is A. So multiply C and B, right? You can just multiply C and B. So this will be 2 minus 5 and 1 0. So you will get CB as, okay, if you multiply that is going to be 2 only, 1 by 1. Okay. Now let us go here. What will be the characteristic polynomial for this A? This is A, this is B, this is C. So lambda square, trace of A, that is 3 only, plus 2. Yeah, it is okay. And multiply that, so it will be nothing but 1 and this is 2. So this will be correct answer for this question. Okay, option A is going to be correct. In this case, let us compute lambda square, then it is going to give you trace, that is 3 lambda, and you can find det, that will be nothing but yeah, so that is 2 only. So this is okay, but whether the product is okay or not, let me find. So this is B, this is C, right? So 1, 0 times 1, that is 0, and yeah, so you're not getting anything, right? You will get 0 here only. Okay, you're getting 0, right? So this cannot be correct answer for this question, because CB is not same. Product CB is not going to be same. Now the question is why we say CB must be same. This CB is appearing here, that must be same, guys. Okay, if this guy is same, then CB's product CB must be same. Okay, it's a very simple approach, right? So option B is eliminated. Okay, please don't consider option B. And next, option C. So again you can find here lambda square, trace is nothing but minus 3, that is plus 3 lambda. Okay, I think you know how to find characteristic polynomial for 2 by 2 matrix when you try to find the eigenvalue of the matrix. Lambda square plus 3 lambda, and then you can say that det is gonna be what? Det is going to be det is going to be 2 only, right? Yeah. It is okay, but multiply that. So multiply, if we are multiplying, so it will give you minus 1 plus 3. Yeah, that is 2. So this is also correct. Okay, C is correct. C is gonna be correct. Okay, but can we compute here? Yes. So lambda square plus 3 lambda, and then this is 2 only. Okay, but CB product must be same. So this is 1 plus 2, that will give you 3. So it is not correct. So in this question, A and C is gonna be correct answer for this question. Okay, so if you know linear algebra, then life is very simple, right? So if you want to learn such techniques, see, I'm not going to use anything. My main objective is what? You have to remember this formula first of all, and you don't have to compute entire transfer function. When they say that two systems will be having same transfer functions, so what you have to do here is you have to observe the matrix A and try to compute the characteristic polynomial. If you found that the characteristic polynomial is similar, right, you can say that yeah, eigenvalue is gonna be similar. Okay, two matrices are similar, right, then their characteristic polynomials are similar, right, eigenvalue is gonna be same, right? I have covered this in similarity matrices. What topic was there? There was a topic called similarity of a matrices, right? Similarity of a matrices. Okay, sometimes I become insane teaching linear algebra. Okay, so you don't have to calculate, so you are saving a lot of time. So you can solve this question within 40 to 50 seconds, right, if you know this approach. Since I am explaining you, so I took this much time, right? So I hope this makes sense. So the answer for this question is going to be A and C, since it is MSQ question. Thank you.